In the last video, we left off on checking the values of x1 over y1 and checking if they were equal to the value or ratio of x2 over y2. And we determined, after simplifying our complex fraction, that they are indeed equal and therefore proportional. So in order to determine whether all of the values are proportional, whether this whole table is proportional, we also need to make sure that x3 over y3 and the ratio of x4 over y4 also are equal to x1 over y1. And once we have determined that, then we can say, yes, they are proportional. Now, if you already did that because of the last video ended on that part and you were able to determine everything else, then you can just go ahead and move on, fast forward onto the on your own part. Now, if you have not done that so far, let's go ahead and check out the value of x3 over y3 and determine if that value is proportional to 1 over 6, or what we determined was the simplest form of the first two ratios. Now, x3 over y3 is 3 over 2, a fraction, over 9. And we needed to determine, is that, when we simplify it, equal to 1 over 6? Let's go ahead and do that. We're going to set up our division problem. So that's 3 halves divided by 9. I'm going to keep change flip to avoid getting a decimal. So that's going to be 3 halves times 1 over 9, which is equal to 3 over 18, which can then be reduced, if we divide both numbers by 3, to 1 over 6. And so, yes, this one is also proportional. And then now we're going to check the last value and determine whether that last value is also going to simplify to 1 over 6. And if it does, then we are set. So x over 4 and y over 4, that's 2 over 12, which, if we divide both of these numbers by 2, equals or reduces to 1 over 6. So we have just determined that all of the values have a simplest form of 1 over 6. And because they all have that same simplest form, we can say that, yes, x and y are proportional throughout the entire table. If we ran into any where we had a different number, let's say that this simplified to something like 3 over 7, then we would say, no, it's not proportional. But because we didn't run into that, we can say, yes, it is proportional. The on your own problems, we've got 5 here, are hopefully not too difficult. I encourage you to not overthink it. That's one of the things we need to get into, is not overthinking our problems. So we're going to tell whether the ratios form a proportion or not. And you can either use the method of determining the simplest form of the values, reducing them to their simplest form, and if they have the same simplest fraction, then yes, they are proportional. Or you could use the method of dividing both of the ratios and then determining whether they're equal to one another. So let's go ahead and start with number 1. 1 over 2, or 1 is to 2, and 5 is to 10. Are these proportional? Well, 5/10, you probably recognize that 5 is half of 10. So 5/10 can simplify down to 1/2. And so because they both have the same fraction in simplest form, we would say, yes, they are proportional. Number 2, we're going to handle in the same way. We're going to have 4 over 6, and we're going to determine, are they proportional? Are they equal to one another? Is 4 to 6 the same as 18 to 24? Let's go ahead and reduce them to the simplest form. If you divide 4 over 6 by 2, then this is going to turn into 2 over 3. And then 18 over 24, that can be divided by 2, but it can also be divided by 6. And that's going to be probably the largest number we can do with that. So let's do divide by 6. And 6 goes into 18 3 times. 6 goes into 24 4 times. And so you can see here that we have now 2 different values. We have 2/3 and 3/4 in simplest form. And so we would say, no, these values are not proportional because their simplest form isn't equal to one another. And neither would their quotients, because this would be 0.6 repeating and 3/4 would be 0.75. And so they also wouldn't have the same decimal answer, and therefore would not be proportional. Okay, number 3, we've got 10/3, and is that equal to 5 over 6? Well, both of these fractions, hopefully you notice that both are already in simplest form. I'm going to make a note of that. Already in simplest form. And because they're already in simplest form and they're not equal to one another, we would just simply say no, they are not proportional. Another thing to notice too, because I think that it's something that could kind of trip you up a little bit, is that on the bottom numbers, the denominators, 3 to get to 6 is to multiply by 2, but 10 to get to 5 is to divide by 2. And so because you're not doing the same operation, we don't consider these equal to one another. Because, for example, going back to numbers 1 and 2, 1 to get to 5, you would multiply by 5, and 2 to get to 10, you would also multiply by 5. And so on that first example, you could see that we have the same operation, while on number 3, we have different operations. And because we have different operations, we would say that no, they are not proportional to one another. And they were already in simplest form also, so that facilitated our process. Okay, let's check number 4. For number 4, we're comparing 25 is to 20 as 15 is to 12. We can reduce both of these values down. We can reduce 25 over 20. We can divide that by 5. And then 15 and 12, we can divide that by 3. I'm going to put it over here on the side. 25 is divided by 5 equals 5. 20 divided by 5 equals 4. And then let's see if that's equal to 15 divided by 3 is also 5. And 12 divided by 3 is 4. Yes, they do have the same simplest form, so they are proportional to one another. And then the very last one that we have is number 5, where we're going to have kind of like the problem we did in the example, and we're going to tell whether the x and the y values are proportional. Now, if you want to move on to the next page because it has plenty of working space, that is totally fine. And we need to determine, is the values of x and y proportional to one another? And I'm just going to write them as their fraction form. So 2 over 24, 4 over 48, and 6 over 12. So if I reduce these 4 fractions, 6 over 72, my bad. If I reduce these 4 fractions, or these 4 ratios, into their simplest form, are they all the same simplest form? And if they are proportional. Well, 1 over 12 is already in simplest form, so we're just going to keep that as 1 over 12. 2 over 24, the only number that's going to go into both 2 and 24 is going to be 2, so we're going to divide both of those numbers by 2. 2 divided by 2 is 1. 24 divided by 2 is 12. 4 over 48, 2 can go into both of those, but so can 4. Hopefully you recognize that. That 4 can go into 4 one time, and 4 goes into 48 12 times. So it's looking like we're going to be having a proportional relationship here. We just have to make sure that the last one is also proportional. 6 to 72, both of those numbers can be divided by 6. 6 goes into 6 one time, into 72 12 times. And so, yes, they are all indeed proportional. So don't forget to write a summary, just 1 or 2 sentences about what you learned today. You can look back at the objective. The objective for today's lesson was to determine whether 2 ratios are equivalent, and if they are equivalent, that means they're proportional. So maybe you could write something like, in this lesson, I learned that if 2 ratios are equal to one another in their simplest form, then they are called proportional.